Hey guys, what's up? Jackson here. So today we're going to be, uh, as a comment request, explaining factoring. So because going into this video, I'm going to assume that someone has tried to teach you factoring before, whether it be a teacher, an online class, a textbook, and it just hasn't really clicked with you. So for that reason, instead of just going over, I guess, the most traditional way of teaching it, I'm just going to explain it the way I understand it. Um, and it may seem like kind of silly or dumb, but like I'm pretty good at math. I got a 770 out of 800 for the SAT. Not saying that to flex, just so you know you can somewhat trust me. But anyways, let's first start with what factoring even means. So the definition of factoring is pretty intuitive. It stems from the word factor, which is just something that makes up or it's a cause for something as a whole. So like the parts of a whole basically. So like if we have this little three ring symbol right here, you could say that the factors of that three ring symbol are each individual ring. With numbers, it's the same thing. Let's say we have 6. We can say that the factors of this number, 2, 2, 2, because 6 is made of 2 plus 2 plus 2. However, because once we get to like big numbers like 600, no one's going to be writing out how many 2s would that be? 300 2s? So that's why we just use multiplication instead. Instead of 2 plus 2 plus 2, we'd say that the factors of 6 are 2 and 3, because it takes 3 2s to make 6. Let's try something else now. Let's say 18. So 18, 2 is always, if it's an even number, it's always going to have a factor that is divisible by 2, unless it is the number 2 itself, or 0. But I don't really consider that an even or odd number. So, yeah. So 2 and 9 would be factors of 18. You could also say 3 and 6. And I believe that's it. So now that we kind of understand that, let's add 20. Let me think here. 24. Actually, let me do a perfect square. 25 x squared. What would be the factors of this? Well, instead of looking at this as a whole, it's way easier to just look at the individual parts. So the 25 first is simply 5 times 5. And the reason why, I don't know if I explained this, but factors don't include 1. Okay, here in the video, I actually make a mistake. Factors do include 1. But I think I correct it later in the video. I'm going to keep talking as if I was in the video again. So we have 5 and 5, and then for x squared, we can just do x times x. So you'll notice that this is essentially 5x squared. Just think about it. 5 is being squared, but we're doing 5 times 5 to get the 25, and x is being squared to get the x squared. So we can actually, if we view them as 2 separate things, like we have our 5 squared and our x squared, which looks pretty similar to what's up here already. The difference is, or let me make sure I'm pointing to. The difference between this and this is that the x is in a parentheses. So anything else in that parentheses is also going to be squared. Whereas like this 25 right here, because it's not in parentheses, we do not square it, even though there's a square symbol here. However, if it was like 25x squared, that would be completely different than 25x squared. That would be 25 times 25, 625x squared. I'm not going to write that out, but you get the point. So because we know part of it is 5 squared, part of it is x squared, but we know that because when two numbers are next to each other, or a number and a variable, it basically just means we're multiplying. So this symbol, or I guess not symbol, but what's the word? What do you call it? Unit? I don't know. Doesn't matter. What was I saying? Oh yeah. When two things are next to each other, it just means you're multiplying. So 25 times x squared, this and this are equivalent. So with that being said, we broke down the 25 and 5 squared. We broke down the x into x squared. So since these are next to each other, it also means we can multiply these. So since both of them are being squared too, we can actually just put both of them inside the parentheses to get 5x squared. And that would be the factored version of 25x squared. So now let's clear everything. So now what we're going to do is, what are we going to do? So the thing about factoring is you basically just have to practice a lot to be good at it, because there's, unlike other concepts of math, factoring there's not a one method meets all kind of thing. You have to learn a bunch of different methods to be able to factor. So we're just going to speed through those methods, and yeah, hopefully I can explain them in a way that makes sense. Actually, before we do that, I actually want to get rid of a common misconception a lot of people have about factoring. Let's say we have x squared plus minus 5x plus 10. This is a completely valid equation. If we put this in a calculator and made it graph it out, it would give us an equation, a graph. However, how would we factor this? Because normally they say it has to add to a times b, and it has to add to b through two factors. I guess in this case it would be -5, and multiply to a times c. And because I'm saying a, b, c, I realized I didn't really explain what that was. So this is essentially, you'll see this a lot. This is just the equation of a parabola, I believe. Ax squared plus bx plus c. So to factor anything in this form, you find two numbers that multiply to a times c. So that's why I was saying 1 and 10, because this x squared basically has an invisible 1 by it. As you can multiply anything by 1 and it doesn't change. So 1 times 10 is 10. And we need two numbers that multiply to 10 and add to -5. So we can say, okay, what are the factors of 10? 5 and 2. We can add those together, to get 7, but that's not -5. We do -5 times -2, still we get -7 and not -5. And the reason I'm showing you this, because this actually cannot be factored. This is in its simple form already. The thing is, with factoring problems that you'll get at school, it'll give you equations that are always they're almost always factorable, unless it's like a trick question. But I've literally never had a factoring question where the answer is just what it started as. I think that's kind of misleading because it kind of builds this presumption that you can factor anything if you know how to do it, but that's just not true. A lot of things cannot be factored. However, they usually give equations that are factorable using a method that you have already learned. So, for example, instead of x squared minus 5x plus 10, it could be plus 6. Because we know factors of 6 are 2 and 3. And also -2 and -3. Because you can multiply two negatives by each other and get a positive. So this factored, now that we have our two factor thingies, we just plop an x here and -2. Plop an x here, do -3. And that's our answer. So instead of just saying like, this is how you factor, this is how you get the answer, I'm going to explain what it means so it makes sense. So for this equation right here, let's try plugging in 2 for x and 3 for x and see what happens. So if we plug in 2 squared minus 5x, which is -10, plus 6, so just 6. So when we combine all these numbers, and by combine I mean add together, I'll try and not use the word combine, I'll say add and multiply, because combine is kind of ambiguous. We get 0, and that's basically what, at least for this scenario, when you get a factored form like this, those factors, for here, it's actually 2 and 3. You'd think, why isn't it -2 and -3? Well, think about it like this. If x minus 2, let's just say we took that by itself and brought it over here, right? X minus 2, let's just set it equal to 0, right? X wouldn't be equal to 2. Because remember, we have to have our variables on one side and our whole numbers on the other. So we do +2 to both sides. Let me just write that out so we're all on the same page here. +2 to both sides. And that would give us x equals 2, actually. Hopefully my screen's not cut off. Sometimes it is. Okay, yeah, you can see that. So yeah. So when you have x minus 2 times x minus 3, that would mean the signs are swapped. The factors would be +2, +3. So that's how you factor something like that. But this is not factorable because there's no two numbers that multiply to 10 and add to -5. Now let's try a different example. Let's say we have 5x squared plus, I'm just writing stuff down to remember. We have x squared plus 2x plus 1. Multiply to 1, add to 2. Yeah, okay. By the way, I wrote that down because this is factorable. It just ends up as x plus 1 times x plus 1. And I would write out the other x plus 1, but since we're multiplying the same thing twice, or the same thing by itself, we can just put a square root sign there, or a squared sign there. So yeah, the reason I did that is because I believe if I multiply b by 5, if I multiplied 2 by 5, because that was the b from the original one, and it was plus 1 before, so just multiply that by 5. So how would we factor this? And starting here is where things get subjective, and there's actually multiple different ways you can do it. And some people in math don't even like agree on the correct way to like simplify something. So there's a lot of stuff in math. Out of any subject, math should be the one where there's only one, I guess, right answer. If you have an answer to something, it should be, yeah, that's correct, or yeah, that's wrong. But sometimes it's actually, it would be more correct to do it like this. Some people will say, no, you should do it like this. There's just a lot of stuff in math that is unfortunately not catered towards people actually trying to learn it, but it is what it is. So yeah, we're just going to tackle this the same way how we did the other one. So a times c is 25. So we need something that multiplies to 25 and adds to 10. And because 25, a perfect square is a number that if you put a square root sign, it'll give you a whole number. So like, because 5 times 5 is 25, or let me rephrase it. 5 squared is 25, and 25 is a perfect square because of that. So anyways, so 5 and 5 are our things here. So let's see here, let me think. So if I did this, this wouldn't give me the correct answer, because let's just try it out and see what happens. So we do x times x squared, then x times 5, which is plus 5x. Then we have 5 times x plus 5x. And then 5 times 5, which is 25. So yeah, basically every single part of this, or hold up, I erased one 5x. So it is actually 2 plus 5x's, which becomes 10x's, or 10x, and then plus 25. So yeah, this is incorrect. So question is, how can we fix it? Well, when a is a number that is not 1, the first thing I would always try to do is see if there is a GCF for the whole equation. So a GCF is basically just means greatest common factor, which means is there a number that this can be divided by other than 1? And there actually is, 5. So if we divide all of this by 5, whoops, we get 5x squared, because 5 times x squared is 5x squared, plus 2x, because 5 times 2x is 10x. Or, I mean, I guess if you wanted to do this intuitively, you would divide 10x by 5 to get 2x. Divide 5 by 5 to get 1. So now, this equation, as we saw before, a times c is 1. What number multiplies to 1 and adds to 2? That's just 1 twice. So that in the parentheses is x plus 1 squared. But now, since we have this 5 on the outside, all we have to do is literally just put it on the 5 on the outside. So this would be the factored form of that. So if you think about it too, it makes sense. You could say for this one, A or B was correct, but A and C were not correct. I believe A was 1 when we multiplied these two together, and C was 25. So we could say, okay, we're problem solvers, right? So what if we just put a 5 on the outside and then did x plus 1 x plus 1. That way, the 5, because the x squared needs to be multiplied by 5, right? So that accomplishes this. Another way to think about it could be, we tried x plus 5x plus 5. That didn't work. So what if we, instead of having 5 twice, because remember, when we had plus 5, that gave us c for 25. And when we had x and x, that gave us an a of 1. So our a was too low and our c was too high. So intuitively, we can think, okay, well, what if I make the x value in the parentheses higher by 5, and the number value, I guess you could say, divided by 5. What answer would that give me? Okay, so let's try it. So we do 5x times x. That gives us 5x squared. Then we do 1 times x. So 5x squared plus x plus 5. Because 1 times 5 is 5. So now we have our a correct and our c correct, but our b is 1. So the reason why I'm doing this in all these incorrect ways is to show that even if you don't know necessarily how to do something, like the exact way, this would be the proper way to solve this problem. But there are always other ways. So we tried essentially just using logic to factor it out. We tried x plus 5, x plus 5. That makes logical sense, right? And that didn't work. And then we tried, okay, what if we change the numbers up a little bit? And that didn't work either. So that's it for that. We tried that and it didn't work. So now we know that doesn't work. And okay, you'd say, why are you wasting my time right now? Think about it. If you're able to try stuff, if you have an idea, always try it and see if it works. Because if it doesn't work, then you know for the future that it doesn't work. So you're never going to try it again. But if it does work, then you just gained an understanding of something on a deeper level than what is taught, which is awesome. And that happens a lot. Math is not a solved thing, I guess. There's people in the world that are just really well versed in math and they know all the tips and tricks. But most math teachers I've met aren't actually like that. They usually know like one standard way of doing something. And if you come up with another way, they'll often be like, huh, I didn't know that. I remember in 6th grade, we were doing how to find the square root of different numbers, like 72, for example. And the way they taught it was find the factors of 72, write out every single factor. For example, 36 and 2, 18 and 4. 9 and 8. And then you do a bunch of other complicated stuff. And it would take forever, but you'd get an answer. However, I'd seen a Khan Academy video. I guess I didn't really come up with a way, but this is an example of there being another way of doing something that the teacher doesn't know. And the Khan Academy way was just make a little branching, you could say like the roots of a tree, kind of, if that was the tree. So what two numbers multiply to 72? 2 and 36. What two numbers multiply to 36? 6 and 6. And what two numbers multiply to 6? 2 and 3. And since there's 2 6s, we know that there's 2 2s. I'll try and write it over here. 2, 3. So my handwriting is incredibly beautiful and very easy to interpret. However, I'm going to explain it just in case there's some misunderstandings. So yeah, we have 72 here, right? We go to 2 to 36 because we found two numbers that multiply together to 72, which is 2 times 36. 6 and 6 multiply to 36. 2 and 3 and multiply to 6. We end up with the ends of our branches. We have 2, 2, 3, 2, 3. When you do this method, the end of your branches will always be, or will pretty much always be prime numbers. Well, they'll always be prime numbers, but there's usually a lot of 2s and 3s. So we did these numbers right here that are at the ends of the branches, those are what's important. All of this nonsense we don't really need. That just helped us get to the good stuff. So basically now, if you have 2 of one number on the end of your branches, you can basically upgrade it and move it to the outside of the square roots. So we have 2 2s, so we can move that to the outside. We have 3 2s, right? But we can keep 1 2 on the outside, and that leaves 1 left over, so that goes on the inside. We have 2 3s, so those evenly go to the outside without leftovers. So writing this out would be 6 times the square root of 2, and that would be the simplified form of the square root of 72. Real quick, I want to go over basically what we've learned so far. And you might think, I have learned nothing. I haven't understood the point of any of this. Which is, yeah, that's actually what I expect. Except this ax squared plus bx plus c. Equations in this form, I believe they're called quadratics. So we know how to do, I guess we can say, a factoring. Let me move it more to the top right so it doesn't get in the way of our work. Okay. Factoring checklist. And I'll probably fast forward this part because it's going to take me a while. Whoops. I'm sure almost everyone knows how to do this because it's one of the first things I teach. If you don't, that's fine. I make these videos to help you understand stuff. But you'll notice how I have factoring checklist and not how to factor. Because I'll ask it as a question, actually. How do you factor? Simple question, right? Well, the answer is question mark. Because factoring is weird because it's a bunch of different strategies and you have to know basically all of them or have a decent understanding of them. Because the question, how do you factor, you really can't answer that with one sentence. So that's why we have this checklist here. so we can understand basically every situation with numbers and how to deal with those situations. So we got this one right. Now let's go back to our original problem over here. So we learned that one way to do this would be taking, dividing all this by 5, because the greatest common factor is 5. That's always a good first step to do, by the way, when factoring something. See if they can all be divided by a number other than 1. And that worked over here, but sometimes there isn't a greatest common factor, and A doesn't equal 1 too. So let me find a good example of that. 4x squared plus 8x minus 5. So you can try dividing all these numbers by stuff like 2. So let's try that. 4 divides by 2, 8 divides by 2, but 5 does not divide by 2. And obviously it doesn't divide by 5, so there's no greatest common factor. Oh, terms, that's the word I was thinking of before, or trying to think of at least. So what do we do? So now this is where we get fancy, okay? So what we're going to do is we're still going to do A times C, right? And, well, I guess it would be C includes the sign. So 4 times negative 5 is negative 20, right? So now what adds to 8 and multiplies to negative 20? Isn't there literally just like... Oh yeah. Okay, so sometimes you will find numbers, right? And you'll be like, aha. 10 or negative 2. Negative 2 times 10 multiplies to negative 20. And 10 minus 2 is 8. So we're like, nice. We did it. But remember, because A is not 1, this is not going to give us this. So shoot, what the frick are we supposed to do? So this is where we get fancy, right? If you have an equation, a method of factoring doesn't work. First off, not all equations can be factored, like I said before, but the example I have found here can be factored. It's just A times C add up to B, blah, 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 didn't fully work. So when that happens, that's when you pull out the other strategies. And there's one strategy called grouping, which is super duper useful. And honestly, I kind of wish they taught this first, because I think grouping conceptually is a key part of factoring, but they teach you it after they teach you the A times C adds up to B thing, right? So what grouping is basically when we have a B value that doesn't work, or when we have an A that isn't 1, this whole A times C thing, it technically works, but we also have to do grouping to get the right answer. So I'll show you why. So we tried it normally. We couldn't find a parentheses combo that gave us this full equation. So now we try grouping. Okay, so what grouping is instead of, if you don't have a greatest common factor between 3 terms, it's like, well, aren't we just stuck then? Actually, no. The thing about grouping is instead of finding the greatest common factor of 3 terms, you pull a big brain and you say, you know what? What if there wasn't 3 terms? What if there was 4 terms? So what you do is So 4 times negative 5 is negative 20, right? And we learned that negative 2 times 10 is a way to do that. That gives you positive 8 and multiplies to negative 20. So we're actually going to convert the b into 10x. Forgot the x. Minus 2x. Minus 5. And you might be like, whoa, 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 hold your horses. You can't just change the value of the equation. And to that I say, we didn't change the value of the equation. 8x is the same thing as 10x minus 2x. But now, here's the cool part. We can actually find the greatest common factor of two terms. So 4x squared minus 2x are both divisible by 2. So we can put a 2 here. Let me just write out what that would be. So 4x squared divided by 2 is 2x squared. Oh, I was actually incorrect. The greatest common factor between 4x squared and negative 2x is actually 2x. And 4x squared divided by 2x is 2x again. Negative 2x divided by 2x is negative 1. So now we have our other two terms here, which I'll circle. Their greatest common factor is just 5, because 10x can be divided by 5, and negative 5 can be divided by 5. We do a 5 here. 10x divided by 5 is 2x. And negative 5 divided by 5 is negative 1. Once we have it in this form, you will notice that 2x minus 1 happens 2 times. And because it happens 2 times, we know we can actually... Well, this is kind of just something you're going to have to trust me with. Once you get it down to this form, basically, you take the stuff in the parentheses, 2x minus 1, and then your other parentheses, you do the stuff on the outside, so 2x plus 5. I was going to say because it appears twice, you square it, but remember, this is adding, not multiplying. These two things aren't multiplying. So we're essentially just simplifying it. Instead of doing 2x times 2x minus 1, and then adding 5 times 2x minus 1, we're just doing 2x plus 5 times 2x minus 1. So this would be the answer in its most factored form. And you actually could also do that with this here. Even though we found the greatest common factor before, and we solved from there, you also could just do the method I just described, grouping. So 5 times 5 is 25, right? But we can't just do x plus 5 times x plus 5. We tried that, it didn't work. So we're going to try the grouping method. We're going to turn 10x into 5x plus 5x. So we didn't change the value of the equation. We just changed it visually. These two equations are 100% the exact same value. They just look different, so we can work with it. These two numbers are divisible by 5x, and these two numbers are divisible by 5. So 5x x plus 5 would be 1. I made a mistake there. I'll probably realize it in a second. Plus 5. 5x divided by 5, x plus 1. So, oh, sorry, I made a mistake. The answer should not be 5 in that parentheses. It should be 1. Because we divided 5x by 5x. That's another important thing. Saying stuff out loud while you do it, or in your head, can help you catch when you make mistakes. But anyways, this simplifies to 5x plus 5. X plus 1. And that would be our final answer. But not actually, but I'll mention that in a second. You'll notice it's actually pretty much exactly what we got before. Because before, when we did it by taking out 5 first, we got x squared plus 2x plus 1, which was just x plus 1 squared. So this was our final answer. So you'll look at this, and you'll look at this, and you'll be like, Jackson, those are 2 different numbers, or 2 different things, right? Which one is the correct answer? Generally, I would say, okay, the one I'm circling is not more correct. I made a mistake here. Factoring can give you multiple different answers at the end, but there's usually something you can do to make them equivalent. So now I'll just continue copying what I said. Basically what we did here, the grouping method, is essentially always going to get you the answer to these ax squared plus bx plus c. Or I guess I should ax squared plus bx plus c problems. So now we go back to our factoring checklist, right? We know how to do this. And now we know how to do this. And a does not equal 1. Under this, I'll put the strategy that's used. We use grouping here. Okay, so here in the video, I am just kind of trying to figure out a way to show what we've already learned without rewriting all of it. So I'm going to skip to where I think I don't. Yeah, I just think here a lot. So give me a second. When you have, let's look at 5x plus 5. The goal of factoring is to get rid of every, I guess, to make like something together, like 5x squared plus 10x plus 5, into multiplied parts. So we can actually divide 5x plus 5 by 5. Whoops, that's not 5. And that actually just gives us five times x plus 1, which is 5 times x plus 1 squared. So yeah, we make a lot of mistakes on this channel. I will edit. Okay, yeah, this is where I talk about editing it. Okay, moving on. So this is what we got so far. Pretty good progress, pretty good progress. Now let's look at some other stuff. Let's say we have 4x to the 4th plus 2x squared plus 2. How would we approach this? What I would do is actually the same thing, that ax squared plus bx plus c, or actually no, with grouping is like kind of a combination of the ax squared plus bx plus c. It's just like making that method possible by changing the equation. So what two numbers multiply to a times c, which is 8, and add to 2. So what numbers multiply to 8 and add to 2? No numbers. So that means this is not factorable. But what we can do, hold up. Okay, I'm going to change it up a bit. Let's make that negative. Okay, so let's solve this problem real quick, and then there's something I want to say. So a times c is -8, -4 times 2. So what multiplies to -8 adds to 2? That would be, oh, remember, we don't want to do the parentheses thing, because a isn't 1 here. So we're actually going to use grouping. And the a times c thing is like a part of grouping, which is why I didn't write it on the list before, but I think it's important to have there. It's weird, they start by teaching parts of grouping, but not teaching group. I don't know if there's a better way to teach it, but it's just, I think that's why it's confusing, is the order it's taught, it doesn't like build off of itself. It's more like teaching you parts of how to do something that works for specific scenarios, instead of just teaching you the whole thing together. You know what I mean? It's just, why not start with the big circle? And then, I don't know. Anyways. -2. Okay, -8. So that would be, yes, -2, +4, because that adds to 2. So -2x squared plus 4x squared plus 2. Wham. Bam. Find the GCF. 4x squared, it would seem, for this. Then we have -4x to the cubed is just divided by 4x squared is -x squared plus 1 from 4x squared divided by 4x squared. Then we have -2x squared plus 2. Greatest common factor between those. You could say it's negative or +2 here. And like, but since this is negative right here, if we made the outside negative, it would make the inside positive. If you don't get what I'm saying, I'll kind of explain why I'm keeping this positive as I do it. So +2 minus x squared plus 1. So the reason I divided by 2 for -2, x squared and 2, instead of -2, is technically you can do either or, but if I did -2, then it would flip the signs of everything in the parentheses. So that become positive, and that become negative, which would mean these two terms are different, and when you do grouping, you want the terms in the parentheses to be the same. So like sometimes you kind of just have to use common sense a little bit. So our answer would be 4x squared plus 2 times negative x squared plus 1. And also because both of these are divisible by 2, we can factor it even further to get this is our final answer. So yeah, I just went on that whole rant about understanding stuff conceptually rather than memorization. I think that's really going to come and help here. So what I'm going to do is I'm going to write an equation that we've already done. X squared plus 2x plus 1. We know this can be factored. A times c, 1 multiplies to 1 adds to 2. It's just x plus 1 times x plus 1. And if we wanted to double check, or just understand why x plus 1 times x plus 1 gives us this, you just multiply. X times x is x squared. X times 1 is x, so plus x. 1 times x is plus x again. And 1 times 1 is 1. So we got x squared plus x plus 1. If there's plus x twice, we can just put 2x plus 1. So you should always be able to get your original equation when you multiply the stuff that is your answer. So why did I just do that? I'm trying to help you understand the properties of parentheses. So x plus 1 times x plus 1 gives us x squared plus 2x plus 1. What if we did x plus 1, x minus 1? What would that give you? Well, for now, I'm just going to do it the math way and show you. But later, I want to see if you can find a pattern, which will help you later. So x times x is x squared. X times negative 1 is minus x. 1 times x is plus x. And 1 times negative 1 is negative 1. So we got x squared minus x plus x minus 1. So negative x plus x is just 0, so it cancels out. Actually, I won't cross it out. I don't always like doing that. So those will cancel out, and you'll just be left with x squared minus 1. So that would be this equation right here would give you, when you factor it, it would give you these. Remember, b is still here technically. It's just b equals 0. So what multiplies to negative 1 and adds to 0? Well, 1 times negative 1 is negative 1. And 1 minus 1 is 0. So there's no b here. Now I want to show you another equation. Let's say x squared plus 4x plus 2. So let's just solve this one way, right? Multiplies to 2, adds to 4. 2 times 2. 2 times 2 is... Wait a minute. That's incorrect. 2 times 2 is not 2. 2 times 2 is 4. And 2 plus 2 is 4. That's something I've found interesting. I'm a nerd. I just really like math. So we got x plus 2 times x plus 2. And again, just to really drive in, I guess the point I'm trying to make, I'm going to multiply x plus 2 by x plus 2 again. Now, it may seem like I'm wasting your time. What the frick? Just trust the process. Trust the process. X times x is x squared. X times 2, whoops, is 2x. Then we have 2 times x, which is 2x again. Then we have 2 times 2, which is 4. So just to, in case, it's kind of just a random thing. It's not super relevant. But you may notice in this right here, and this right here, it may remind you of something. Hopefully I didn't delete it like a dummy. It may remind you of, it may look like something that we've done before, like this right here. Like this with this. You may see a pattern. That's all I'm going to say about that for now. Okay. So we combine 2x plus 2x is 4x, so we get x squared plus 4x plus 4, which is our original equation. Now, given what we know about x plus 1 times x plus 1, and what happened when we did x plus 1, x minus 1, what do you think is going to happen when we do x plus 2, x minus 2? Pattern recognition, I think, is one of the most important things, or the most important skills you can have when learning math, because everything is connected. It's just they're not taught like they're connected, which is kind of dumb, but it makes sense. Teachers are just trying to have the best class average. Woohoo. They are teachers more. Anyways, it's probably a good idea if I actually show you the last one and what we got for it before we find a pattern. So we did x plus 1 and x minus 1, and we got x squared minus 1 as our answer. So what do you think this is going to be? Well, I'm going to use my brain. I'm going to be like, okay, x squared minus 1. The x stays the same. So the way I teach stuff, I guess, the way I like to teach it is like those memes where it's like a bunch of red dots and string connected to like a spider web that you'd see like a detective use or something. And it's like a bunch of seemingly unrelated stuff. And I'm just saying it's all connected. For a second, forget what I said about the x plus 2, x minus 2. What happens when you do x plus 1 times x plus 1 versus x plus 1, x minus 1? This was our answer from that, and this was our answer from that. There's two differences. One, for this one, b is gone. Why is that? Let's think about that logically. Well, when we multiplied x times 1, 1 times x, that gave us plus x. For this one, when we multiplied, we did x times negative 1, which is negative x, then 1 times x, which is positive x. So those cancel out to give you no b, essentially. And that is something that also applies to here. So we know b is going to cancel out, because if the pattern from over here holds true, which it may not, you know, not all patterns, like this is a very small sample size of data. but we're trying to see if our theory works. But in theory, our theory works. Oh, also one more thing. The other difference between this and this is that C is negative instead of positive. So let's take this and apply that logic to it. So we get rid of B, so no B, and we make C negative. So in theory, this equals x squared minus 4. Interesting, interesting. Another thing I want to note is 1 times 1 equals 1, 2 times 2 equals 4. All I'm going to say. So now, I've got more space. Nice. Let's say we have x squared plus 6x plus 9. So what can we do with this? Well, if we were to solve it normally, blah, 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 we get x plus 3 times x plus 3. So now, let me ask you this. Only looking at this, or actually looking at this, we know x squared plus 6x plus 9 is equal to x plus 3 times x plus 3. What would be the equation? What would the equation look like if it was x plus 3 times x minus 3? Okay, well, let's just use the pattern from before. B goes away, so A stays the same. B goes away, so no B. And C, actually, B goes away, put an X through that, just to show that we have no B, even though I exit out. It looks like the X variable, which is probably confusing. Sorry about that. And C becomes negative, so positive 9 becomes negative 9. And yeah, I will tell you, that does factor out to x plus 3, x minus 3. And this is actually a key rule of factoring that I'm trying to get at here. Instead of teaching you the rule and why the rule is the way it is, I guess I'm trying to teach a pattern that you can recognize. So when I teach the rule makes sense. I guess I'm trying to help you like discover the rule for yourself in a way. So okay, now, so before we did, if x squared plus 6x plus 9 gives you x plus 3, what does x plus 3, x minus 3 give you? We said that gives you x squared minus 9. Just to show, we went from x plus 3 to x minus 3 to x squared minus 9. I'm going to put that on the bottom. Start with that. End up with this. And we got this. We got this without any multiplication, no nothing. Just purely pattern recognition. B goes away. C becomes negative. So this is x plus 3, x minus 3 goes to x squared minus 9. So let's say we start with, I don't know, x squared minus 16. Given this pattern over here, what do you think a factored form of this would be? And if you thought x plus 4, x minus 4, you'd be correct. So here's the pattern I'm trying to help you realize. When We don't have B. We just have A and C. And C is negative and a perfect square, which basically just means one number can be squared to get that number that is a whole number. So like all the perfect squares, 1 times 1 is 1, 2 times 2 is 4. So 4 is a perfect square. 3 times 3 is 9. So 9 is a perfect square, and so on and so forth. So when C is negative on a perfect square, your parentheses that you get from it, like the factored version, is just going to be x plus square root of the perfect square, and then x minus the square root of the perfect square. And the reason, like, this minus sign is important is, like, you might think, okay, with that logic, x squared plus 16 must be x plus 4, x plus 4. But remember, let me see if I can find it. I think it's here. Yeah. When we have only positive numbers, we did x squared to get x times x to get x squared. We got plus x twice, so we had a b value. So this would not be x plus 4, x plus 4. That would actually, when you multiply this out, would give you x squared plus 8x plus 16. So hopefully, it doesn't have to make perfect sense. Again, this is something you have to practice a lot to understand, but if you have x squared minus a perfect square, you know you can just factor it as x plus the square root of that perfect square, x minus the square root of that perfect square. So I'm going to add that to our list. Yeah, so here I'm just writing down all the stuff we just found out, pretty much. I do make a mistake here. I put n equals perfect square when it should be n equals the square root of a perfect square. I don't know if I correct it later. Other than that, yeah, so that's one thing we discovered. The x squared minus n squared is equal to x plus n, x minus n. When stuff is written out like this sometimes, it's hard to connect it back to what we just did. So just, when that happens, just plug in numbers. So, let's say x squared minus 9 squared, or x squared minus 3 squared. So that's x squared minus 9. So that becomes x plus 3, x minus 3. So, like, make sure that you understand, I guess, when you see a rule or whatever, visually what it means. And it's just the same thing we did before. So x squared plus n squared. Now, what does that equal? Remember, we know it's not x plus n twice. Okay, hopefully you didn't pause the video to try and figure that out, because there actually is no answer. The answer is, if you have x squared, so it's like you have x squared plus 9, where n would be 3. There's no way to factor that. It's just not doable. And why is that? Why is that? I like to view it like yin and yang. Our negative n, let me scroll down a little bit. Our negative n is our yin. Actually, I feel like it should be. You know what? I keep. That is our yin. And our positive n is our yang. Is there a bucket tool? Aha. Bam. So yeah, when you have your yin and yang, let's just think about what the yin and yang mean. So because one n is negative and one n is positive, that means that we're going to get minus nx and plus nx. So the yin and yang cancel out. So we have no b. But at the end, remember, you always have to multiply negative n by positive n. And when you multiply a negative number by a positive number, you always get a negative number. So like positive times positive equals positive. Negative times negative equals positive. But positive times negative equals negative. So like with this and this, we always get extra stuff, like plus 2b or minus 2x, because we get like plus x or minus x. But with the negative, we have one positive, one negative, and they cancel out. So we get this beautiful, we can have beautiful things like x squared minus 9 going to x plus 3, x minus 3. Or the other way around. It could be x minus 3, x plus 3. But unfortunately, when we have something like x squared plus 9, it's like if we, let's just think about it in reverse, right? If we have x plus 3, for this example right here, positive n was our yang, I think. I don't know what it's called. Actually, let me erase the 3. That is not what the... Let me erase that. I'm going to replace the 3 with an n, just to keep things consistent. So our positive n is our yin, and let me actually fill it up real quick, make sure it's connected. And our positive n is also yin. So we have yin and yin. Look how ugly this is. You can smush these two things together as much as you want. It's always going to be an ugly mess. So, with that being said, let's erase all of this. Hopefully, I was able to make some point there for you. And instead, we're not going to write x squared plus n squared. Because remember, positive, when the thing is positive, it's like double yin, ugly mess. You hate to see it. But what it gives us is 2n. But it's not plus n minus n, because it's plus n, or minus n. In this case, plus n. So x squared plus 2n plus n squared is what gives us x plus n times x plus n. Now, what if we had x squared minus 2n? Or actually, let's work in reverse. If I had x minus n times x minus n, what would that give us? Now, it might be tempting to say, okay, x times x stays the same. We have minus 2n, and then we have minus n squared, right? But remember, negative times negative equals positive. So negative n times negative n is the same thing as positive n times positive n. So it would actually be x squared minus 2n plus n squared. Okay, another thing I want to point out. So you've likely seen something similar to this before if you have been taught factoring. But the way it's usually visualized, instead of saying x plus n, it'll just be x plus n squared. Which is fine, but it's like by writing it like that, it's kind of hard to visualize, I guess, why this is the way it is. And also with x plus n, x minus n, you can't simplify that. Like, it's not x plus n squared, it's not x minus n squared. So what do you write it as? Well, you just write it fully. So that's why I'm writing them all out fully, just to show that these are very similar concepts in nature. It's just these two can be simplified to x plus n squared and x minus n squared, and this one can't. But who cares? We're not going to do that. Okay. So we've made some very, very good progress. Very, very good progress. I'm thinking I'm going to make this a two-parter, because this video has gone long enough as is.